uh, so now this is the linked list problem. Let's do this. We have 6 problems. Again, this is blind curated series, the linked list problems. Let's do them. Remove nth node from end of list. Okay. Remove nth node from end of list. So this is, let me, so if you see this, right, we have 1 2 3 4 5. So we have 1. How do I use a color? 1 1 2 3 4 and 5. And then uh, we need to n equals to 2. So if we have, this is, if we consider this 1 2 3 4 and 5, the reverse is 1 2. So this node should be removed, 3 4 and 5, right? So now what we know is, given a linked list, remove nth node from the end and return its head. So we need to remove 1 3 4 5. So how do we remove? We know that this that next is this, this that next is this, and somehow we need to make, we need this dot next as this, right? And since the difference is 2, what we can do is just think about this. If we have this difference as 2 from first 1 and then 3, the next time we move, we maintain this spacing, right? So it will be here, that is 2 and 4, and next time we move, we have uh, 3 and 5. So we still have a difference of 2 here. Now we know that, okay, this step next is completed, so we can assume, since the difference is 2 already, 1 and 2, so the final will be, from here it will be 1 and 2. So now if this fast or forward pointer dot next is null, then this back pointer dot next can be back pointer dot next, right? uh, so let's do that. So let's say, like here we have two, we have we will need 2 pointers. So let's call them list node forward pointer, which is equals to head for now, and list node back pointer, which is also head. Now what we need to do is, we need to fast forward this uh, front 2 times while so let's do that. While n is greater than 0, and then also notice here that if this value is not present, I mean if the value, the tooth value is not present, then fast pointer will throw an error. So while this and both of these conditions will satisfy, forward pointer dot next is not equals to null, then what we can do is, forward pointer is equals to forward pointer dot next, right? And then we can simply do n minus minus. So now what we know is, okay, how to erase all this? Can I move this? New. It is too slow, guys. Okay, now we are here. Our fast moved here. What if uh, what if we want to find the difference is 3, 1, 2, and then the third difference is off? That means 1, 2, 3. Yeah. So is there something that, okay, the given n will always be valid. So that means if you see this, right, uh, so 1, so let's say the difference is 3, and we maintain, okay, forward, that is 1, 2, and 3, and or even 1, 2, the next is null, and if we need to remove the 2 from this point, there is 1, 2, we can simply remove from head, right? uh, yeah, or 3. So basically, if forward pointer, let's just keep it like this because there was 3 space, but we'll check. Forward pointer equals to null, then return that next, right? If this was a bit confusing, let's say we have 1, 2, 3, and n is also 3. So from here, the third will be 1, 2, and 3. So this element needs to be removed. This is our first pointer. What happens now is first pointer goes n equals to 2 here, n equals to 1 here, and then n equals to 0 on first pointer is null. So when the first pointer is null, we can simply say, okay, this is it, right? Yeah, that's what we did. Yep. Now we will also need, like we explained earlier, back pointer, which we already have here. Now while this forward pointer is not equals to null, we'll increase both, right? That will be like forward pointer dot next is our forward pointer, and list node of back pointer is equals to back pointer dot next, and back pointer dot next equals to back pointer dot next return head. Okay, so let's see what happened here. Mhm. Okay, so let's try to submit this. Okay, cool. This is done. Yeah, because we need that empty space should be used, right? So go till here. That was missing. Remove nth node is done. Now merge to sorted list. I have already opened here. Okay, now since these two lists are sorted, 1 2 3 and 5 6 9 7 10 12 13, something like this, right? So what we do is, say, whenever we are going to merge these two, the first is 1 and the result should be sorted, because this is still bigger, this is still bigger, so 2, still bigger, 3. Now the 5 should be pulled, so 3 should point here, right? And then 5 next is 6 and 6 next should be 7, because these are both in parallel, and 7 next should be, it will check against itself and below, so it will pick this, and since everything is null here, we'll simply return this, right? uh, so the idea is, let's do this. Okay, we already have list node, so if we know if list node equals to null, then we can simply return list 2, right? Similarly, if list 2 is null, then we can simply return list 1. Now to merge, if list 1 dot next, or list 1 is list 1 dot value, or this is still in C++, should have known seeing the pointers, but that's fine. If list node dot value is smaller than list 2 dot value, right? Yeah, if they are equal, then anything is fine, else we'll simply return 1. Then we can simply return, or what we can do is, yeah, L1 dot next. So since this is small, so this dot next is the merge of, we can utilize this merge of L1 dot next. Since we already have L1, then we'll merge these two, L1 dot next comma L2, right? Else, yeah, once we do this, then that's fine. Else what we can do, if this was smaller, then what we can do is, if let's say if yeah, if this one is greater, if, let's say this one was 4, then um, what happens if this is smaller? Then L2 dot next. So wherever we have the L2, if this is greater, then L2 dot next is equals to merge L1 and L2 dot next, and L2 dot next, right? So if we do this, I think we can simply return L1, and for this scenario we can simply return L2, right? Yep. Okay, cool. Now merge k sorted list. Yeah, okay, this is, the previous one was just 2 and this is multiple ones. Let's I think we can reuse the same code. How do we so whenever there are two lists, we can of course merge them with merge to list, right? Okay, okay, now this will give us a merged list. So what we can do is, for okay for equals to 0 till list dot length I plus plus. So basically, if we have so this one was for 2 linked lists. Now what if we have 1, 2, 3, 4, 5, something like this? One way is to just merge all these together and combine them, or we can simply build from this, right? We already have this. How about we merge these two and merge the remaining with this, merge the remaining with this? We can go like that. So that's why I have this for loop. Our first element is we already know that's L0. So what we'll do is uh, we'll simply return list 0, right? And then list 0 will be the merged to list of list 0 and list I, right? We can do this, and then also what we can do is if this list 0 is empty, just saying if list dot length equals to 0, then return what do we return if list is not? Return none. Is that it? Let me just test this. Yep. And then what if it's this? We should be fine. Yeah, it's just 5%. What we can do is we can actually pull so the better way to do it is put every queue first element in a queue, right? Put a priority queue of all these numbers, and since priority key will sort it, and from everything we'll just append it, and then we can go forward. I can do that also. If you want me to, just let me know in comments, then I'll solve it like that. But this works, not bad. I'm just appending to the same list and merging, just reusing the code, right? Okay, now has cycle. Whenever we have, let's consider this example. This is a marathon track, and somebody starts from this point, and if two of the pointer, first person and second person, let's consider them as two pointers, the second person runs twice as fast as this first pointer. So let's say this is divided like this into equal spaces, right? When the first pointer is here, the second pointer will be here. When the first reaches here, the second will reach here, right? When the first reach here, the second will reach here. When the first reach here, the second will reach here, right? This is the second will complete one cycle, right? So second has completed. Now when it reaches here, this will reach again here. When it reaches here, the slow pointer, the fast pointer comes here, and whenever it reaches here, they both meet. So basically, whenever we are running through a circle, the fast pointer will run twice to come to the same point, while the slow pointer will run one point and come to the same point, visit at same point. So that's what we will use here. So let's say we have a list node of fast, which is head, and list node of slow, which is also head. we'll keep them going in the same pace. So while uh, so there is a saying like, okay, why don't we, since we are only returning, we don't want the index. I thought that was the question. This is just, okay, if it has a cycle or not. Then what we can do is we can simply put like this, try to go forward, and if there is no null, then it is true, right? Basically what I'm saying is try else catch. Just fail fast. If there is an error, that means a null was visited. Return false. Return false. Else return while fast is not is equals to slow. What we'll keep on doing is fast is equal to fast at next dot next, and slow is equals to slow dot next. So we are moving one fast pointer in twice the speed as this slow pointer. So return true. Now if so, so by this theorem, whenever they run in a loop, they will meet at some point, right? Whenever they start from somewhere, anywhere, whenever one is running twice the speed and one is running at slow speed, they will eventually meet at some point, and that point is, sorry, and that point is where we return true. I mean that at that point we know if fast and slow are same, it will break the loop and return true. And if the fast is null, it will throw an exception and it will simply return false. I think that is fine. Oopsie. What is output is true? Okay, that is fine. Now reorder list and reverse linked list. Okay, let's do the reverse linked list first. This is again Java, because yeah, so reversing should be fine, right? So list node previous is not. So, okay, let me try to explain this also. So we have this, so we want to reverse a linked list. How do we do that, right? So this is pointing here, this is pointing here, this is pointing here, this is pointing here. So now what we want to do is 1, 2, this is 3, 4 and 5. Now what we want to do is, let's say we want to do 1 should be pointed by 2, and this should be pointed by 3, pointed by 4, pointed by 5, right? Now to do this, how do we do it? See, if we consider this is our previous element, then this current element, so this dot next, our current element dot next was this value, right? So what we want to do is this values, previous value, we want to point to the previous pointer, and that's how we simply put this here and this here. So just to do that, for example, our here this is null at first, so let's just keep it like that. Okay, our previous element is null, and while so while this head is not equals to null, we can simply work with the current. This node current equals to head, and while our current is not equals to null. So let's see, we have few pointers, 1 2 3 4. Our current is here, this is our current, and our next node is this, right? So this, so this will point here. So for now it is pointing it like this, and we have our previous here, which is null at first, right? Now what we do is, okay, let's just put this next in some order so that we know, okay, list node next is equals to our current dot next, right? Okay, we have this next. Now current dot next, now since this current dot next is next, we want to move this current dot next as previous, right? So that this points to the other direction. So list node so what was I doing here? Dot next, basically current dot next will be our previous element, that way the current pointed to this one. Now our previous becomes this value because this will be our next. So now we move this previous to here. So now our previous becomes whatever is current, right? And our current has to move to this value, right? Next. So our current has to move to next, and if we keep on doing like this, finally this 4 will return to 3, and this is our previous, this will become our previous. So we'll simply return 3. Okay, now server is in maintenance. Okay, now reorder list. Reorder list, what we have is, we have 1 2 3 4 1 4 3 2 1 2 3 4 5 becomes this. So what it's saying is, given a list, we need L0, then L1, then Ln, then L1 n minus 1. So basically 1, then last, then second, then third. So what it is saying is, let's say we have 1 2 3 4 nodes. We want this first, and then this, and then this, right? So this is how it should be. So what it basically means is, we have one list of any size. If we divide it, then what we can say is, okay, this points here, and just to make it like this, what we can do is, since after this will come, right? So how about we reverse this? This is 4 and 3. If we reverse this, it will be 4 gives to 3, and this one is 1 2. We keep it as is, and we have 1 2 4 and 3. So if we merge these two, now we have 1, and then the second 4, and then 2, and then 3. So the output will be like this, right? So to do that, let's code. So we'll do it something similar to this. So just to know where to break, we need a half point. So we will need to two pointers. One is a slow pointer. Let's note slow, which belongs to head, and one is let's note fast, which also belongs to, let's say, head for now. So now let's see, while since we are moving the fast 2 times, so let's say our fast is, well, fast is not equals to null. Fast is equals to fast dot next. Now if fast dot next is null, it will throw an error. So fast fast.next equals to null, while this is not equals to null and this is not equals to null. Similarly, slow will be slow.next. So if we see this, what happens now is we have 1, 2, 3, 4. So our fast and slow start from here. So whenever slow reaches here, fast reaches here, and whenever slow reaches here, fast is null, right? Whenever slow reaches here. So now since we want to break at this point and we need this as, so because the next of this is where we want to break, and we want to keep this as null. So the next of this we want to make this as null, so as that this is a new list which will reverse, and so that it will be 1, 2 and 3, 4, right? So we'll simply make this as null. So to do that, let's introduce another variable, list node previous. So it will keep track of what all our previous values were before moving to the next. So let's just say, okay, prev is whatever slow we have, and that slow changed, right? Now again here what we saw was if fast reaches the null if the size is odd. If it was even, then fast.next would have been the null. So based on that fact, we can say that if fast equals to null, then this is a even list, right? Yeah. So if it is even, we should be good. What we can do is, okay, we can simply say, okay, previous dot next equals to null. So no matter what, so let's just say, okay, previous dot next equals to null. And if it was odd, let's see how the list would be. 1, 2, 3, 4 and 5. So whenever, since we are starting fast and slow together, whenever slow reaches here, fast reaches here. Whenever slow reaches here, fast reaches here, right? And since this is null, it will just break. So our previous here is this. So what we can do is we can start from here, or because I think since this is going to come at last, it doesn't really matter. Anyways, so anyway, this our previous is now null. So since previous dot next is null, let's just keep on going forward. So what we'll do now is, as a part of this, what we saw is whatever is our this slow, we'll simply reverse it, right? Slow. Also, if you look at this, our slow will be the next value of it. We don't want to slow this. So if the length is odd, we want to make our slow as the next value. Slow. If fast is null, so in odd scenario, when fast, that means fast is not null. What we'll do is we'll simply make slow equals to slow.next, so that it points from slow equals to slow.next. Did we get a chance to say, okay, this one, because fast reads next, so we simply take this and we can simply make again previous is equals to slow, right? So this is the odd scenario. Now what we have is we have two lists, one separated in their midpoint. Now we can simply reverse this second part, that is the slow being is the second part. Okay, we have this handy, right? Okay. This node, again, this slow is equals to slow will be reverse list whatever is slow, and our, we can simply say, okay, list node first is our head, list node second is our reverse or slow, we can simply assign the same slow or anything is fine. Now these two are there. What we want to do is we simply want to merge these two, right? So return the merge of so since this head should come first, so let's just put it here, head and second. So public this node of head and this node of second. And now to do the merge, just like previous, if second equals to null, we will simply return head. If head, this is just a basic check. Since one length is longer, the other is not required, but still, if either can be null. Return second, right? And now what we'll do is again, so we have the head. Head dot next is, so head dot next is, what is it? Okay, public this noise. So we have this head dot next is merge of second again first, right? So simply put the second again, our first is head, sorry, head dot next. So if we do it like this and then finally return head, I think we should be good. Let's see. Okay, merge. Oh, this one was a void. Okay. Yeah, anyway, we are not introducing any new variables, so should be fine. Uh-oh. Let's see. Okay, we only have one, two. Oh, Mars. Cool. 1, 2, 1, 2, 5. Things should be fine. Uh-oh, not pointing. If a equals to null. Okay, cool. Alrighty, I think we did all of this. Thank you guys. Have a good night.